A quiet lab hums as the camera reveals a wall of screens tracing the inner workings of a cutting-edge AI brain. Researchers at Tsinghua University have identified a tiny set of neurons, less than 0.1%, that seem to trigger AI hallucinations. These H-neurons act like switches, and flicking them can steer whether the AI follows faulty instructions or sticks to the truth. For the first time, scientists can visualize how a machine's inner neurons relate to its tendency to lie or mislead. The team used a trivia dataset to probe the model, asking many variations of questions to detect when an answer was truly correct. If the AI answers correctly every time, the answer is marked as real. If it consistently errs and fabricates, it's labeled an illusion. A measurement framework called CETT records the contribution of each neuron when the model spells out an answer. Researchers paid special attention to moments when the word Einstein popped up, mapping which neurons fired at that instant. The data allowed creation of a sparse linear classifier that could predict whether an answer was real or a hallucination just from neuron activity. A striking finding, the classifier gave almost all weight to a tiny set of neurons, the H-neurons. These H-neurons make up less than 0.1% of the model, yet they act like a signal light, indicating potential fabrication. To test robustness, the researchers challenged the model with questions across ordinary knowledge, cross-domain expertise, and entirely fictional prompts. In every scenario, detectors based on H-neuron activity outperformed random neuron checks, pointing to a universal internal pattern of storytelling. Next, the team tested what happens if you dial up or suppress H-neuron activity during answer generation. Increasing activity makes the AI more obedient, but often blindly so, accepting faulty premises and misleading context. Decreasing activity sharpens honesty, as the AI questions premises and resists unsafe or misleading prompts. The core insight is that oversimplified truth claims are not the same as factual accuracy. It's a matter of overcompliance. Thus, hallucinations are not just errors, they reflect a drive to appease the user's demand for a fast answer. The researchers conclude that the seed of hallucinations planted during pre-training when the model learns to predict the next word for fluency, not factuality. Subsequent instruction tuning makes AI more helpful, but does not fix this foundational tendency because the seeds were already sown. The practical promise is clear. Targeting H-neurons could ease hallucinations without retraining the entire model. Or we could rethink pre-training goals to better model uncertainty and fact-checking from the ground up. In brief, a rare class of neurons lights the path to honesty or fabrication in AI behavior. This discovery reframes how we approach AI safety, linking truthfulness with the brain's intrinsic control signals. Even as questions remain, the finding shows a path toward more honest, reliable AI assistance in the near future. The final question is when these quirky neurons form, during early pre-training or during later instruction tuning. The study finds H-neurons exist in the base model prior to fine-tuning, indicating early roots of the storytelling circuit. Fine-tuning hardly alters these neurons, meaning later training mostly preserves them while adding new behavior layers. The takeaway is clear: the seed is planted early, and subsequent training amplifies subtle tendencies rather than erasing them. This insight invites redesign of pre-training objectives to better model uncertainty and to temper the urge to please for a quick answer. In sum, H-neurons reveal a universal internal pattern behind AI storytelling, a tug between fluency and factuality. The researcher's message is hopeful. Intervene at the neuron level or redesign the learning goals to reduce hallucinations at the source. This work points to a future where AI assistants are more honest, capable, and safe by design. The science behind AI hallucinations is becoming clearer, guiding safer development of intelligent systems for everyday use. If you enjoyed this exploration, consider the tiny sparks inside networks that power big questions about truth and trust in machines.